Lesson 16, Charge, Current, Voltage, and Ohm's Law. Electric current is given the symbol capital I. For further reading on this information, visit your reference textbook in the content library, pages 319 to 323. Electric current is defined as the rate of flow of electric charge, and the SI unit is the ampere, amps for short, and the symbol is capital A. In the mid-1700s, Benjamin Franklin, a well-known American scientist, flew a kite during a lightning storm to investigate the nature of electricity. He decided that when describing electricity, an excess of electricity, or the charge that makes up the electricity, is positive, and a deficit of electricity is negative. In other words, the charge moves from the positive terminal to the negative terminal of the source of electric potential. His assumption about the direction of electric current was called conventional current, or just electric current. Conventional current is defined as the electric current charge that moves from the positive terminal through the circuit to the negative terminal. Now, electron flow theory, this method of describing the direction of electric current is referred to as electron flow. The negatively charged electrons move from the negative terminal through the circuit to the positive terminal. Electric current comes in two forms: direct current and alternating current. Direct current flows in one direction only. This is the type of energy that is found inside your cell phone battery, your solar cells, and in most of your small electronic devices. Alternating current is current that moves back and forth, i.e. alternates in direction, and is a more efficient method of distributing electrical energy. This is the type of energy that is found in your wall outlets and in your generators. Some people visualize electric current as an actual continuous flow of charges that start at the energy source, travel through the wires to the load, and then return to the source. Electric current does not happen that way. The electrons throughout the wire are ready to move as soon as the switch is turned on, just like water is ready to flow before a tap is turned on. To produce a current, all the electrons need is a push, the electric force, from the source, which occurs as soon as the circuit is closed. As a result of the push, the electrons that are in the load give up energy. When we measure current, we use an ammeter. An ammeter is a device that measures the amount of electric current in a circuit. It's connected directly into the path of moving charges as shown. This type of connection is called a series connection. The symbol for electric ammeter is a circle with an A around it. Note, a current of 0.016 amps is sometimes referred to as the let-go threshold because if the current is above this value, the person cannot let go of the object giving the electric shock. Current is what you really need to pay attention to, especially when you're talking about electrical safety. And know that this value of 0.016 is the value at which any current above this will not allow your hands to let go of whatever you are being electrocuted by. And this is because the current is high enough that it will actually send the electric charge through your muscles and disable your muscles' own electric stimulation to allow you to release that. The second electrical quantity that we're going to look at is electric potential difference. You can read more on this topic, pages 324 to 327, in the reference section or the reference textbook in your content library. The symbol for electric potential difference is the capital letter V. It's defined as the difference in electric potential between 2 points in a circuit. It's also called voltage. and it's what you would more commonly refer to as voltage in everyday life. The SI unit for voltage, or electric potential difference, is the volt, and the volt is given the symbol capital V. When you're measuring electric potential difference, you need a different device, not an ammeter. This time you need a voltmeter. The electric potential difference between 2 points in a circuit is measured with a device known as a voltmeter. It is connected across the path of the moving charges. As shown in this type of connection, it's called a parallel connection. So the circuit symbol for a voltmeter is the letter V inside a circle, similar to that of the ammeter, where it's the letter A inside a circle. It's used to measure the potential difference between 2 points in a circuit, and as we mentioned above, it's connected in parallel with the load. Note, in an ideal circuit, the connecting wires and control device do not affect the amount of electric potential and therefore do not cause a voltage drop. However, in a real circuit, the connecting wires and control device do cause a voltage drop. So let's draw a circuit diagram showing a 2-cell battery, a closed switch, and a light bulb. If you wanted to measure the current flowing past that light bulb, you would have to attach a voltmeter in series with that light bulb. What we mean by in series is that it is along the same straight line path. Whereas if you were to measure potential difference or voltage across that same light bulb, you have to connect it in parallel. So we'll draw our light bulb, and we would attach a voltmeter like so. 2 branches, one on each side of the load, and connect it in what we call a parallel connection. So the ammeter is connected in series, and the voltmeter is connected in parallel. The third quantity we're going to look at is electrical resistance. This is given the symbol capital R. To read more on this topic, look at your reference text, pages 328, 332, and you can find this in the content library on the LMS page. Electrical resistance is the degree to which a substance resists the flow of electric current through it. The SI unit is ohms and is given the Greek symbol omega. Resistors are electrical devices that have specific resistance. There are many different types of resistors. For example, lightweight carbon resistors are used in electronics, and heavier ceramic resistors are used in larger circuits. Dimmer switches and the volume controls on a stereo are examples of variable resistors, resistors that allow you to change their resistance. A resistor is defined as any material that can slow the flow of electric current. And the electric symbol that we use, the circuit symbol for a resistor, looks like this. Looks like a zigzag pattern. So if you take a look at this circuit symbol, we have a 3-cell battery, we have an ammeter to measure the current, we have a resistor, and we have a voltmeter to measure the drop in voltage or the potential difference across the resistor. Now, German physicist George Ohm used the ratio to formulate Ohm's law, and Ohm's law states that as long as the temperature remains constant, the potential difference is equal to the current times the resistance. So Ohm's law can be summarized in this equation. Another way to write this is to isolate it for resistance, and resistance is equal to potential difference over current. These two are equivalent. They are the same. Any material that obeys Ohm's law is said to be ohmic. And an ohmic resistor, if you were to plot the potential difference versus current, you would get a straight line. If you get a straight line, that indicates that the resistor is ohmic. If you get anything else other than a straight line, we say it's a non-ohmic material. So if there's a curved line, it's a non-ohmic resistor. So, as long as temperature stays constant, V is equal to I times R. Let's do an example. Calculate the voltage drop across a resistor with a resistance of 220 ohms and a current of 1.2 amps. So in this question, we are given a resistance of 220 ohms and a current of 1.2 amps. And what we want to find is the voltage drop, which is the same thing as the potential difference. So we know from Ohm's law that V is equal to I times R. So that's 1.2 amps times 220 ohms. If you punch this into your calculator, you should get a potential difference or a voltage drop of 264 volts. I want you to try the homework practice questions below, and when you're done these, please log on to the LMS and complete the corresponding LMS quiz. Good luck.